Yes, let's continue with the next topic, students. It is peer-to-peer applications. Till now, whatever the concepts we have seen so far, it was all following client server architecture. I hope at the beginning you must have studied about client server architecture and peer-to-peer architecture, correct? Yes. So here till now we were speaking about client server architecture. So now we will move on to the next architecture, that is peer-to-peer architecture. So we'll just see few applications which actually follows peer-to-peer architecture. Okay. Yes. Let's see what is this peer-to-peer architecture. Yes. I hope you all must be knowing the concepts of peer-to-peer. Yeah. So basically client server means what? Just see this block diagram. These are all laptops, and you can assume that all these laptops are acting as clients. And you have this black boxes. What are these? Servers. And here you see all these clients are basically requesting the remote. This is a phone, right? Yeah. All these a phone, maybe a person who is sitting inside the car, maybe using a phone, or maybe he must be using any other device and is traveling there. And all these are laptops which are movable. Phone is also anyways, it is portable, and all these are acting as clients, and all their requests are sent to remote servers, right? And in client server architecture, these servers are burdened with the requests of n number of clients. Maybe those clients are still clients, that is fixed to a particular place, or maybe they are portable clients. They are moving from one place to the other. So all these requests are redirected to the remote servers. And in client server, a server has to always send a response rather than any other system. It is servers who will respond, and those servers should be 24/7 on. Right? So this is actually the concept of client server architecture. So client's job is just to upload the data. Server's job is just to upload the data to clients as per the client's request. Client's job is first to send the request to server. Server's job is to upload the content which the client has requested, and once the uploaded data reaches the client's job is to download those contents, right? So downloading is happening in client, whereas uploading is happening in server, right, by the server. So this client downloading and uploading is actually taking a lot of time in client server application. So in order to reduce that, we have the next architecture, that is peer-to-peer. What is peer-to-peer? Here, instead of burdening these system servers, we just convert our clients itself as servers. So our system is acting both as client as well as server, correct? So what is the meaning of a system acting both as client and server? Say here, I'll just see this small network, and in this network there are two systems. These two systems are acting as both clients and server. What is the meaning of that? See, this is my system and this is my brother's system. Both of us are in the same house, right? Yes, you can see a house, and here I'm sitting and here my brother is using the laptop. So what am I doing there? I have a collection. Basically, I have collection of some movies. My brother will have a collection of movies. So whatever the collection I have, my brother may not be having. What my brother has, I may not be having. My system won't be having, right? So what do we do there? If I want to share any movies to my brother, or if I want some movies from my brother, what do I have to do? I have to send. Basically, I have to upload the movies to my brother's system, whereas my brother has to upload his movies to my system. So what is that happening now? My system will act as a server for my brother. That is, he is actually requesting for some movies now, and I become the server wherein I'll be uploading movies to him. Similarly, when I want some movies from him, so I'll be requesting, whereas my brother's system will be acting as a server. So brother's server, that is his system, will be uploading movies to my system. So what is happening there? Peer-to-peer communication is happening. What is a peer? Peer is nothing but a system which is acting both as a client and a server. Here my system acts as a client when I'm requesting for something, and my own system acts as a server when I'm getting the requested contents. My system acts as a server when I start uploading movies or when I start uploading contents to some other requesting clients. So in that case, my system acts as a server, right? So peer is the one where one system acts as both client and server. Now tell me whether the single server's burden is reduced. Yes, the burden is reduced to a greater extent on a single server. Why? Because initially I might have downloaded the movies from one server. Suppose if I'm using netflix.com, I might have downloaded the movies from Netflix server. So that initial downloading is happening through server only. But after that, whatever movies I have downloaded and my collections what I have, I can start uploading as a server. My system can act as a server now. Why? Because I can act as a server now. I can start uploading on behalf of Netflix. I can start uploading the movies to some other systems, right? Wherein my system acts as a server now, right? So now in that case, other clients need not directly consult Netflix server. So other clients directly can contact my system, wherein I will be acting as a server now to upload the movies to other system. So this is actually peer-to-peer communication, wherein the burden on a server, single server, is reduced to a greater extent. So some examples for such peer-to-peer architecture, some application, you might have used BitTorrent application or streaming application like Kankan or some, obviously like Skype. So all these are following peer-to-peer architecture. All these are peer-to-peer applications examples. Okay, BitTorrent, it may be Kankan or it may be Skype. All these are following peer-to-peer architecture. Okay, why? Because here no dedicated server is available. Here all systems access servers, right? Okay. Okay, next you just see now, we'll just see how the time reduces, how the distribution time reduces. Okay, first we will just see the client server architecture, how the distribution time is calculated here, and we'll see next the peer-to-peer architecture, there how the distribution time is calculated, and we'll see which is better there. Okay, first of all, what is the meaning of distribution here? Distribution time is nothing but the time taken by a system to distribute file among all the clients. That is, time taken by a server to distribute files to all n servers. Okay, suppose if I have a file which is stored in a server, file F which is stored in a server, F in the sense file which has F bits. For example, if I have a server, if I have something like 100 MB file, 1 GB file will take 1 GB file in a server. That 1 GB file should be sent to, say, suppose here how many clients I have? 1, 2, 3, 4. Total 4 clients I have. So all 4 clients should be getting this 1 GB file completely. So all 4 clients should be able to download successfully 1 GB file in their system. In that case, once this is done successfully, once the downloading is done successfully, I can say that my file is distributed successfully. This is the distribution, and the time taken here for the server to distribute this 1 GB file for all 4 clients, we call it as distribution time. Okay, so what are the different parameters we have to consider for calculating the distribution time? We will see. First is the uploading rate. Server should have certain rate, certain capacity to upload the data. What do I mean by capacity or rate? So for example, the server has to upload how much data here? 1 GB data, right? But at one server cannot upload complete 1 GB file. So it has to send part by part, right? So suppose for every 1 second, our server is able to send 100 MB data. For every 1 second, 100 megabytes of data if server is able to transfer, then the server's upload rate becomes 100 MB per second. For every 1 second, 100 MB data only it will be able to upload. So that becomes 100 MB is the uploading rate of server. So what about this clients now? Client's work is only to download the data, right? So downloading rate of our client also should be certain to a certain level, right? So what should be the downloading rate? This downloading rate of the client, it should be something like, to download this F bits, this should have certain rate. For example, if it has the downloading rate as 50 MB per second, okay, 50 MB per second, 50 MB per second. So what is that? For every 1 second, the client is able to download up to only 50 MB. correct. So only 50 MB. So suppose if the if our client wants to download completely this file whose size is 1 GB, whether this 50 MB downloading rate is enough? Not enough, right? It is very less. So its downloading speed should be increased, downloading rate should be increased. If I want to increase my downloading rate, what should I do? Simple. My bandwidth should be more. That's all. I should have more bandwidth. Either I should buy more bandwidth or I should, that's all. I have to increase my bandwidth by buying. That's all. I have to pay more and get the bandwidth, get more bandwidth. That's all. Okay, right? That's what is thing happening there. Okay, so uploading rate and downloading rate. Okay, so now this is the diagram what you all can see. Yes, so here you can see the server's uploading rate. This is the downloading rate D1 of client 1, downloading rate D2 of client 2, downloading rate D3, D4. It continues up to n clients. Okay, and this is about our client server. And if I convert the same architecture into peer-to-peer, in that case, see, this is the first server what we have when it uploads the data, and our client's job is to download the uploaded contents. Plus, our clients also will start behaving as peer. It will also starts behaving as servers now, right? So, what is our client's job now? Once it downloads the data, that will also start uploading. So, that is a peer's job. Every peer has a capacity to upload the data. In that case, so upload 1, upload 2, upload 3, up to upload n. These are all the rates, different uploading rate of different peers. Okay, so this is what is shown. Now, we'll calculate the distribution time. Yes, so we'll just see the distribution time. How distribution time is calculated. Yeah, first we will see the server. We'll calculate the time taken by the server to upload a file whose size is f bits. I said the size of my file, if it is 1 GB, the time taken by our server to upload 1 GB file, if it's okay 1 GB file, okay, is how much? So that all depends on our upload rate of server. So what is upload rate of server? Here US. So in my example, I have taken the upload rate as, for example, 100 MB, right? So for every 1 second, 100 MB data only can be uploaded. But for file containing 1 GB data, 1 GB size, what is the time taken by the total time taken by the server to upload 1 GB file? So that is given by 1 GB divided by 1 GB divided by 100 MB, right? So for 1 second, 100 MB data, but for file containing 1 GB data, what is the time taken? What is the total time taken? That is calculated by cross multiplication. 1 GB divided by 100 MB. Same thing here, generally it is written F, it's 1 GB in my example, divided by US. It's nothing but 100 MB in my example. 1 GB divided by 100 MB. That is the time taken by the server to upload the data. So this one copy of the file, the total time taken to upload one copy of the file is this much, right? Next, time taken to send that copy to all n files. What is it? In client-server architecture, time taken by the server to copy that same uploaded copy to all n clients. What is the time? The total time is n into f. If there are here 4 clients, that means 4 into, multiply by 4 into this 1 GB divided by 100 MB. So n is nothing but 4 number of clients. So n into f divided by US is the total time taken by the server to copy this one file of 1 GB to all the clients. Okay, so this is what is happening here in client server thing, that is the uploading thing. Okay, next comes our downloading in client server architecture. So what is this downloading in client server architecture happening? Yeah, download rate. So for all these clients, in order to completely download this 1 GB file, it should have some minimum downloading capacity. What is that minimum downloading capacity? It's indicated by dmin. So minimum downloading capacity should be dmin. So if its downloading capacity is at least f divided by dmin. What do you mean by f divided by dmin? So for 1 GB, it should have some minimum downloading capacity. So f is 1 GB file size, f divided by minimum downloading capacity. If it is at least that, then a client can successfully download this 1 GB file completely. Not partially, completely it should be able to download this 1 GB file. For that, at least D-min should be the download rate. So this is actually the download rate what is specified for every client. Now the total distribution time in client server architecture to distribute the file for all the client contents, for all the clients, if that file F should be sent successfully by the server, that distribution time is calculated. That distribution time should be greater than, or equal to, actually this is equal to, okay, greater than or equal to what? It should be, first you should compare this uploading rate and the downloading rate, minimum downloading rate. So this uploading rate, if it is higher, and the downloading rate if it is lower, uploading rate is higher, downloading rate is lower. If uploading rate is higher, then your distribution time should be equal to uploading rate. So maximum of these two. So which is maximum in uploading rate and downloading rate? If uploading is higher, then uploading rate is the maximum one. So that distribution time should be equal to your uploading rate. Suppose if the downloading rate is higher compared to uploading rate, in that case, your distribution time will be equal to your downloading rate. So whichever is maximum, either uploading or downloading rate, whichever is maximum, your downloading rate should be matching with that, right? So what is that? The time taken to distribute this file of 1 GB to all 4 clients, all the clients, that time, compare that with the downloading rate of individual client. So when you compare, whichever time is maximum, that duration you fix as the distribution time. So your distribution time will be either equal to that or it should be greater than that. It can never be less than that. Okay, so your distribution time should be greater than, always it should be greater than either uploading or downloading rate, or it can be equal to the maximum of uploading rate or downloading rate. Remember, so that is how you calculate the distribution time in client server architecture. Now same thing we will just see for peer-to-peer architecture. In peer-to-peer architecture, distribution time little varies. So how do you calculate the distribution time? Yeah, in distribution time in peer-to-peer architecture, you just see here, uploading is done once by server. After that, all clients will download, and then uploading again will begin. See here, once server uploads, all clients need not download here, right? 1 or 2 clients will download that file. After downloading those files, these clients will start acting as a server. So they will start uploading that downloaded contents. So when they start uploading, they become the server. Then the other 2 remaining clients can start downloading. So here what is happening? Our clients uploading rate will not matter much, right? So here, yeah, our clients upload, first our servers uploading rate will not matter much. So what is our servers uploading rate here? Same as before, it is F by US rather than N into F by US. This time it has become only F by US. What is the meaning of that? Server will upload only once. It need not wait until all its rate should not be, it need not be the time taken by the server. It need not wait for all the clients to download, right? So it will just upload once and keep quiet. Its work is done. So F by US, it's the uploading rate or the time taken by the server to upload the file. Okay, once it's done, next client will start downloading. Its minimum download rate should be F by D-min. So it's the same. And after that, what is that? The clients, all the clients should be able to download, right? So all the clients will be able to download. So all the clients also should be able to upload there. So uploading also will happen along with the downloading. So their uploading is calculated separately. Downloading is also calculated separately for all these clients. So servers uploading rate is done. So what is that? F by US. And all the clients downloading rate also we know it should be minimum. What is that? F by D-min. F by D-min. It's the same. So apart from that, clients uploading rate also we have to calculate here. And what will be the clients uploading rate this time? It is all clients will act as a server sometimes. So N into F divided by every client's uploading rate you add. So each client's uploading rate here we have U1 add with U2, add with U3, up to UI you take. So along with this uploading of all clients, we have our server also uploading there, right? Add that also. So uploading is happening by server as well as all the clients. So how is that uploading calculation is done? n, it's n clients will get file f, n into f divided by what is the rate of uploading. First our server will upload US, you add that with, now who will start uploading? Clients will start uploading. So US plus U1 plus U2 plus U3 up to UN. So this, when the file, you can say the time taken by the time taken to distribute the file for all n clients is calculated by considering the upload rate of server plus the upload rate of all the clients, correct? So that is how we calculate distribution time in peer-to-peer architecture. Is something like first the upload rate by server. So what is that? F by US, that is initial uploading. After that, download rate of your individual client, you compare F by D min, and after that distribution time for all n clients. So n into F divided by upload rate of server plus upload rate of all the clients. That can be written as sigma UI. This is summation of upload rates of all the clients. Okay, so now you compare all three rates, all three durations, what you have just calculated. Maximum of this will be equal to your distribution time, total distribution time, or your total distribution time should be always greater than the maximum of this. If your upload rate of server is higher, then your distribution time should be either equal to that or it should be greater than that. Or if your downloading rate is greater, then maximum, then your distribution time will be equal to that or greater. Or this uploading rate of all the clients, summation of uploading rate of all the clients, if it is greater, then your distribution time should be equal to that or greater than that. Okay, so now this is little different from your previous client server architecture. So what is a major disadvantage in client server architecture? If the number of clients increases, their client server's efficiency starts decreasing, right? So in my previous thing, you can just see in the client server, when n starts increasing, automatically your efficiency decreases. Why? Because it's a burden on server when number of clients increases, right? Because all clients will start accessing single server there. Whereas in peer-to-peer, this scalability doesn't matter. Scalability here means as the number of clients increases, our server's burden doesn't increase. Why? Because all clients access a peer. So you can just see that comparison here in the form of a graph. See here, blue color graph indicates peer-to-peer architecture, black color thing indicates client-server architecture. Here along x-axis, number of clients is represented, along y-axis, distribution time is represented. You see, as the number of clients increases, total distribution time also starts increasing. So you just see that client-server architecture, when the number of clients were around 1, no? Distribution time was around slightly greater than 0. Say assume it as 0.2 or something. When the number of clients became 2, see here. Sorry. When the number of clients became 2, slowly our distribution time also increased. Again, when it became 3, distribution time increased. When it became 5, it became 0.5 distribution time. Similarly, as the number of clients increased to around 33 or something, total distribution time became more than 3. So your graph started increasing linearly, distribution time increased as the number of clients increased. But in peer-to-peer architecture, you see, as the number of clients increased, distribution time also started increasing. But after certain duration, you just see as the number of clients increased, your graph is not increasing. It is just constant there. It is constant. It is not increasing linearly like in client server architecture. Just see here how it is increasing. Very slightly the distribution time increases. That means what? This is far more better peer-to-peer architecture where your distribution time doesn't increase that much. Correct? So this is how you compare client-server architecture with this. Okay. Now next we will be taking an example of peer-to-peer architecture. So one such example, one such application is BitTorrent. We will see how BitTorrent works. Okay.